Toothpaste is something most people use every single day without a second thought, yet it represents one of the longest evolving personal care products in human history. A material shaped by ancient experiments, medical science, industrial chemistry, and some of the most precise mass production systems in modern factories. What squeezes out of a tube in seconds is the result of centuries of trial and error, and a manufacturing process that balances abrasive strength, chemical stability, hygiene safety, and perfect consistency at massive scale. And today on the How Factory, we're going inside modern toothpaste factories to see exactly how toothpaste is made. From raw ingredients to the smooth, minty paste packed into millions of tubes every day. Humans have been trying to clean their teeth for thousands of years. Ancient civilizations used crushed bones, ash, shells, salt, and herbs to scrub plaque from teeth long before modern dentistry existed. The Romans experimented with powdered charcoal and even abrasive minerals, while early Chinese records describe tooth cleaning paste made from ginseng, salt, and mint. These early mixtures were harsh, inconsistent, and sometimes damaging, but they laid the foundation for the idea that oral hygiene could prevent disease. Modern toothpaste began to emerge in the 19th century when industrial chemistry made it possible to produce safer abrasives and stable paste instead of loose powders. Today's toothpaste is a carefully engineered suspension, a blend of solids, liquids, and active ingredients that must stay evenly mixed, remain stable for years, clean without damaging enamel, taste pleasant, and meet strict health regulations. Producing that balance at industrial scale is far more complex than it appears. The process begins with raw materials arriving at the factory in bulk. These include abrasives such as hydrated silica or calcium carbonate, which physically scrub plaque from teeth. Binders like cellulose gum are used to prevent separation. Humectants such as sorbitol or glycerin keep the paste moist and prevent it from drying out. Surfactants like sodium lauryl sulfate help toothpaste foam, allowing it to spread evenly across teeth. Active ingredients such as fluoride are added to strengthen enamel and prevent cavities. Flavor oils, sweeteners, preservatives, and colorants complete the formula. Each ingredient is stored in dedicated silos, tanks, or sealed containers to prevent contamination. Before production begins, samples are tested for purity, particle size, moisture content, and chemical stability. Even small deviations can affect texture, shelf life, or safety. Production starts with the liquid base. Large stainless steel mixing vessels are charged with purified water, humectants, and liquid stabilizers. These tanks are often equipped with heating jackets to control temperature and high shear mixers to ensure uniform blending. Precise control is essential. If temperature rises too much, binders can clump or degrade. Next, binders are slowly introduced. These powders hydrate over time, thickening the liquid into a gel-like base. This step requires patience and precision. Adding binders too quickly creates lumps that cannot be removed later. The mixture is agitated for extended periods until the binder fully dissolves and forms a smooth structure capable of suspending solid particles evenly. Once the base is ready, abrasives are added. This is one of the most critical steps in toothpaste manufacturing. Abrasive particles must be evenly distributed and suspended without settling. Too coarse and they damage enamel. Too fine and cleaning efficiency drops. Industrial mixers fold the abrasives into the gel under controlled speed and vacuum conditions to eliminate trapped air. Vacuum mixing is essential at this stage. Air bubbles trapped in toothpaste cause inconsistent texture, poor tube filling, and weak product appearance. By mixing under vacuum, manufacturers ensure a dense, smooth paste with uniform consistency. The mixture gradually thickens into the familiar toothpaste body. After the physical structure is complete, active ingredients are introduced. Fluoride compounds are added in carefully controlled amounts. Too little reduces effectiveness, too much becomes unsafe. Computerized dosing systems measure additions down to fractions of a gram per batch. Other therapeutic additives, such as desensitizing agents or antibacterial compounds, are blended in depending on product type. Flavor is added late in the process to preserve volatile oils. Peppermint, spearmint, cinnamon, or proprietary flavor blends are introduced slowly, while mixers distribute them evenly. Sweeteners like saccharin balance bitterness from active ingredients without contributing to tooth decay. At this stage, the toothpaste finally begins to smell and taste familiar. Before the batch is approved, samples are taken to on-site laboratories. Technicians test viscosity, pH, fluoride concentration, microbial safety, foaming behavior, and abrasive index. The paste must flow smoothly, hold its shape on a brush, and remain stable for years without separating. If any parameter is outside tolerance, the batch is adjusted or rejected. Once approved, toothpaste moves to holding tanks that feed the filling lines. These tanks maintain gentle agitation to prevent settling and are sealed to protect against contamination. The environment inside toothpaste factories is tightly controlled, with filtered air, sanitation protocols, and strict hygiene standards. Packaging is where speed and precision meet. Empty toothpaste tubes, typically made from laminated plastic or aluminum plastic composites, arrive flattened and open at one end. Tubes are fed into automated lines where they are expanded into shape using air jets. The open end is positioned upward, ready for filling. High-precision filling machines inject exact amounts of toothpaste into each tube. The process must be fast but gentle to avoid introducing air. Fill weights are checked continuously by automated sensors. Even minor deviations trigger immediate correction or rejection. Once filled, tubes move to sealing stations. The open end is folded and heat-sealed or crimped, depending on tube material. This creates an airtight closure that protects the paste from moisture loss and contamination. Date codes and batch numbers are stamped onto each tube for traceability. Next comes labeling and secondary packaging. Tubes are printed with branding, usage instructions, and regulatory information, either directly on the tube or via sleeves. Finished tubes are grouped into cartons by high-speed robotic packers. Cartons are sealed, labeled, and stacked onto pallets for distribution. Behind the scenes, quality control never stops. Random samples from the packaging line are opened and inspected for fill accuracy, seal strength, appearance, and texture. Long-term stability testing simulates months or years of storage in a matter of weeks by exposing toothpaste to temperature cycles and vibration. Modern toothpaste factories also focus heavily on sustainability. Water used in production is filtered and reused. Packaging materials are continuously redesigned to reduce plastic use while maintaining barrier protection. Many manufacturers now produce recyclable tubes and plant-based formulations, requiring additional process adjustments. What makes toothpaste manufacturing remarkable is how much science is packed into something so ordinary. The paste must clean without scratching, foam without irritating, taste pleasant without sugar, remain stable for years, and deliver medical benefits every time it's used. Achieving that balance at massive scale requires constant monitoring, automation, and refinement. From ancient tooth powders scraped together from ash and bone to modern fluoride-rich pastes engineered at the molecular level, toothpaste reflects the evolution of both medicine and manufacturing. Every tube represents centuries of experimentation and a factory system capable of producing millions of identical products with near-perfect consistency. From bulk chemical storage to vacuum mixers, from precision dosing systems to lightning-fast filling lines, the journey of toothpaste is a hidden industrial process most people never see, yet rely on daily. And that is exactly how toothpaste is formulated, mixed, tested, filled, sealed, and shipped, transforming raw chemicals into a smooth, effective paste that protects billions of smiles around the world. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines, materials, and factories behind everyday products.